Hi, everyone. A warm welcome to today's webinar on AI's impact on the telecommunications domain. It's a pleasure to have you all here for this very exciting session. The topic of today's webinar is latest use cases of AI in telecom, trends and innovations. I'm Rohina Chawla, and I'll be moderating today's session. A few points before we begin. We'll share a recording of the webinar with you all to revisit at your convenience and share ahead. Also, we recommend that you use headphones for a better experience. Lastly, if you have any questions or clarifications during the session, please park them in the Q&A window and we shall take them up at the end. In today's session, we will explore the latest use cases of AI in the telecom industry, highlighting how AI is transforming various aspects of telecom operations. We will also explore how generative AI is revolutionizing customer interactions in real time and learn how AI-driven 5G optimization can improve network slicing and quality of service management. Additionally, we will demonstrate some of the AI use cases to help you understand how these innovations can be applied in real-world telecom scenarios. To take us through the session, joining us is Amantya's VP Engineering, Gaurav Sharma. I will quickly introduce Gaurav before we begin the session. Gaurav has over 2 decades of hands-on experience in the telecom domain, and as a senior leader at Amantya, he is responsible for managing and driving Amantya's advanced AI and wireless services and solution portfolios. So without further delay, I will now hand over the floor to Gaurav.
Yeah, thanks, Rohina, and good evening to all the participants. So thanks for introducing me, Rohina, and for setting up the context for this particular webinar, right? I mean, the way we have structured this particular webinar is what I'll try to do today is share with all of you what we have learned in the past few years. When I say past few years, probably on the AI side, of course, we are relatively new entrant, right? But from a telecom perspective, I mean, we've had a lot of exposure and experience, right? And it's a part of the natural evolution for telecom networks to actually integrate with AI solutions, right? So what we'll do today is, of course, I'll give you some basic introduction about the organization, about what are the kind of products that we have, where does AI lie in our strategy, right? Plus, I also have created few slides that talk about some of the use cases and the impacts of AI in the telecom network. I'll also talk about some of the things that we have been doing in the past year or so, some of the solutions that we have. To add more color to this whole thing, we have also had some demos created for you. And probably I'll also like to talk about 2 or 3 use cases in more details so that all participants can actually appreciate how AI is going to impact things, right? I'll try not to get too much technical into this particular webinar, but yes, at places where we think that talking about few terms, few AI terms makes sense, probably I'll use them. Right. And of course, this will be followed by the question answer scenario. So as Rohina just mentioned, feel free to ask your questions. Okay. I mean, just to give you guys some context here, let me talk a little bit about the organization. So Amantya is a product engineering company wherein we focus on developing some of the next generation technologies and building products around them, right? Primarily, we do more of our products around the telecom domain, right? We have built our own 5G SA core. We have our own user plane function as well. There are products that we built around these IPs as well, right? Which is our network in a box, a small solution for giving instant 5G connectivity, right? We've also done a lot of work around N3 IWF, which actually helps non-3GPP devices connect to, say, a 5G network, right? Plus, one of the other important areas that we have focused into and have been building products for the last 2 years or so, that is on the test automation side, right? So, and these are, by the way, all deployed products with our customers, right? On the testing side, we have our two well-known products, AutoRAN and AutoWi-Fi, right? AutoRAN is something that you use to actually test your radio network, right? Of course, you can do your 5G core testing as well, since this uses real handsets, modems, etc., right? So apart from the whole telecom space, as I mentioned earlier, we have been investing into the AI domain as well, right? And for the past some time, we have been evaluating various initiatives on this. We've been building few solutions around this as well. Recently, we just launched our VonetIQ product as well, which is loss prediction. I'll talk a little bit more about this later in the uh, webinar, right? And I'll give you more background into why we built this product, how does AI come into picture, and how does this fit into the whole telecom background, right? So that's our IP solution, right? The whole idea behind talking about these things is just to establish that as far as telecom networks are concerned, we've had some very good exposure, some very good experience in these areas, right? Plus, of course, it was, as I mentioned earlier, it was natural evolution for us to actually pick up AI and integrate that with our solution, right? Of course, in terms of services, we do a lot of AI strategy and consulting at this point of time. We are into product engineering, data engineering, analytics, and AI into IoT space as well, right? Talking about some general numbers, as you can appreciate, I mean, AI is quite a hot buzzword these days. On the telecom industry side, I mean, it's a growing market, and a lot of market researchers have actually predicted some very good numbers for it, right? So probably by the mid of next decade or so, you'll see close to around 40-50 billion market size for AI within telecom, right? And especially if we look at the way 6G is being written, right? And currently, of course, it's more in the specification writing phase at this point of time. But then that is all going to be around AI. That's going to play a very key role into that. And a lot of learning that is happening at this point of time, that is going into writing these specifications, understanding how AI is going to drive some of the key factors within the telecom network. How do we launch new services, or how does AI come into normal telecom networks? Now, moving forward onto this, okay, let me lay this out for you guys, right? So essentially, there are two things that are happening, right? First is, how does AI actually help in my telecom network, right? Or how does AI actually help me to manage a telecom network, manage services, create new services, launch new services? How does AI impact the end user or consumer? How does AI impact, say, the operator, the operations, people who are directly involved in managing the network? So that's one key piece, right? And I'll talk a little bit more about that as well. But at the same point of time, what is also very essential is that how telecom networks or how the architecture is evolving to actually support all these things, right? That's the other critical or element of this whole big puzzle, right? A lot of work has gone to actually facilitate moving forward or in future. Say if I need to write an AI application, how does my telecom network actually facilitate this whole thing? So that's again a very key area in which a lot of effort has been put in, right? And we'll talk more about this a little bit later, right? But first, let's talk about how AI impacts a telecom network, right? So whenever, so let me just break this down into layer wise, right? So essentially, what is happening in a telecom network, right, are three layers or three things, right? One is, of course, your infrastructure layer. Now, this is the most basic hardware layout, right? That's at the lowest level, right? So things like your physical machines, routers, Ethernets, right? So that sort of connectivity. That's the base layer. On top of that, you have the enablement layer, and this is where some of the standard 5G network functions or some of the standard architecture happens, and plus a little bit of features as well in terms of how does QoS get managed, right? How does slicing happen, right? Which node talks to which node, etc., etc. Right? That's the enablement layer. On top of that is the interesting business application layer. Now, this is where the services part comes into picture, right? When I say services part, right, of course, a lot of telecom services that you or me as an end consumer experience being consumers of a particular network, right? And of course, apart from these three layers, there is this small portion, not small, but yeah, a small piece of the 5G devices as well, right? Now, what we've tried to do is for each layer, right? We've tried to come up with AI-based use cases and how AI can actually help at each of these layers, right? So let's start with the infrastructure layer, right? Now, this is more on the hardware side, right? And the towers or your routers or how your machines get laid out, right? One of the classic use cases for AI is the maintenance and management of this full hardware, right? Now, today, what we have are static rules, right? And static mechanisms in terms of how you see or manage your infrastructure, right? Now, the problem with that approach or the limitation with that approach is that as networks get more complex and complicated, right? And there is this increased dynamism that comes into play, right? These approaches, they have their own limitation, right? Now, to give you a very small example, traditionally, operators have gone with fixed hardware or fixed pieces, right? But of course, as newer networks and then 5G got deployed, right, the whole orchestration scenario changed, right? Now people started talking about, okay, you have congestion at a particular place, right? Now let's orchestrate and let's roll out something on the fly, right? So that brings in a lot of new challenges for the operator, right? And how do you manage these things, right? What AI does typically in here is based on various network scenarios, right? And then there are these huge number of parameters that actually go into making a particular decision. Now, it's humanly not possible to actually take these decisions on the fly, right, in the runtime and manage or orchestrate your telecom network, right? What AI can do here is that it can take those decisions based on multitude of all these parameters and so on. So things like if you're monitoring the health of your infrastructure or you're going to predict this thing that, okay, currently this particular interface or this particular router is experiencing these sort of parameters or KPIs. And the way things stand today, so probably in the next half an hour or so, congestion is going to hit, right? Now, if congestion is going to hit, the AI model definitely can talk to your orchestrator. You can have additional infrastructure integrated within the network, right? Uh, the next or the layer on top of that, that's the enablement layer. And here again, there are a lot of use cases around AI, right? So very simple things like how do you optimize message routing, right? As I mentioned, I mean, with telecom networks and especially with the newer telecom networks, there are so many dynamic things happening, right? Static rules are not going to take you that far, right? So say if one of my nodes, if one of my routers or paths is going to get into a congestion phase, right? Or there is some maintenance that may be required, right? How do you dynamically route messages, right? Or how do you dynamically manage the bandwidth, right? How do you anticipate this thing, right? That probably these factors are coming and congestion is going to play, and then you come up with an alternative path, right? In traditional or olden other networks, right? These decisions were left to operation guys, right? So, which obviously meant that days were lost to actually do this, right? With AI taking these decisions, learning on how to actually take these decisions, this is something wherein AI applications can actually predict that this is going to happen, right? And when I talk about AI models, right? So let's take a very simple example that you have a regression LSTM model, right? Now, essentially, what that does is that there is this management or there is this learning part wherein a lot of historical context goes into training that particular model. There are multiple inputs that go into an LSTM or whatever regression model that you're using to actually predict that, okay, now this particular situation is going to arise. Now, this may be related to your congestion, this may be related to your maintenance, this may be related to providing some SLA-based service and so on. Now, these models can then actually take certain decisions, right? And can reorganize the whole network, right? So things like threat detection, right? So say what is happening within your network, right? So say you have, say, a support vector machine, right? SVM sort of a model, right? That actually classifies good flows versus bad flows, things that you expect to be happening in the network and things you don't expect to be happening within network, right? So SVMs are a very simple mechanism to actually classify these flows, right? So of course, 3GPP gives very detailed specifications on what message flows are possible, what IEs are possible, right? Now you can have a single class SVM, which is trained or which knows that, okay, these flows are valid and these flows are invalid, right? Now during real time, AI can predict that, okay, something wrong is happening within your network, right? And the whole problem with static rules or the way this used to happen was this was more of a post scenario processing, right? So you used to get PCAP logs from the network. Somebody from the engineering or operations side would sit, he would analyze thousands and millions of messages going on, right? And then say that probably something is wrong, right? Now, in a large scale or carrier grade network, doing that manually doesn't make sense. So that's something which is simply not possible, right? And with the increased complexity of these messages, the increased number of integration points within these networks, right? Because with 5G, what essentially 3GPP has done is that it has kind of opened up the network, right? So you have applications out of the 5G network talking to, say, NEF, influencing some of the services that are going within your 5G network, or then you have these integration touch points with other application functions as well, right? So which means that this is a more open network than in traditionally what we had, right? Which also means that there is an increased threat to our networks, right? Herein again, AI models, they can detect anomalies, they can detect security threats, right? There's so many things that you can do with it, right? So that's the enablement layer, right? Here, we're still talking more in terms of how does AI actually directly impact your 5G network, right? Now, the layer on top of that, that's the business application layer. Now, this makes a lot of sense to operators because it is here where revenue actually gets impacted. And where users or end consumers, people like you and me, come into picture, right? So say I am a subscriber or I am a consumer who has taken some special sort of services, right? I need a higher quality of service, right? Maybe guaranteed bandwidth, right? Or maybe there are these emergency services that need better service quality, right? Now, typically and typically what would happen in a traditional static rule-based world is that, say, if there is a congestion, right? What would happen is that most of the calls or a lot of calls would get dropped without understanding the priority of these calls. Of course, in traditional networks as well, there is this concept of priority, but then that isn't as evolved as what AI can bring onto the table, right? Now, here, what we can do is slice management, a lot of priority selection, right? AI models can do that, right? Now, another example could be, say, you have a CDN running on one of your Mac, the edge controllers, right? And I'm a priority subscriber. The AI models predict congestion, right, happening, right? What then they can do is they can get back to your orchestrator, which can then reconfigure your slice or put me onto a dedicated slice, right? Which means that even though congestion is setting in, I can still go ahead and enjoy my services since I'm a premium customer, right? It can also talk to your RAN, right, which is the radio part. It can reconfigure some of the L2, L3 parameters. So things like your symbols, things like your patterns, right? It can provide more bandwidth to the downlink transport, right? And so on. And by the way, even on 5G networks, if you look at this whole O-RAN thing, there is a separate AI components to it, right? So things like near real-time applications or non-real-time applications, right? AI is one of the biggest chunk between them. So traffic steering, right? Or congestion management, QoS management, right? These are all things that that 3GPP or O-RAN, they have identified that this is how the future networks would look like, right? And they would actually help in controlling the network quality, right? So telecom network management, maintenance, congestion control, ensuring QoS, routing bandwidth, that's one part of it, right? Now let's talk about a few more things, how AI comes in, right? Now, say I have an operations team, right, and there are certain bugs or certain call drops that are happening, right? Now, there is this huge data set that I, as an operations guy or an operations team, would have to manage it, right, and would have to see where the failures are, right? So, as I spoke earlier, it can do a lot of log analysis on my behalf, right? So things like standard call flows, conditional, optional parameters, are they coming in the order what is expected? Is there something inexplicable happening within the network, right? So that's the other part. And of course, predictive maintenance, to predict that using LSTMs or other models, regression models, you can actually go ahead and see that, okay, this is one place where, based on some of the KPIs that the network is reporting, congestion may come, right? And it can do predictive maintenance as well. Now, from a customer perspective, a lot of times we do reach out to the customer care, right, and have our complaints, right, or want to check something, right? Now, that is where a lot of custom chatbots, they come into play, right? So that was on the telecom network side. On the devices side as well, AI plays a very important role, right? You have smaller AI models running on the edge devices. Plus, at the same point of time, you have these federated models as well, or distributed models as well, right? So, wherein parts of the AI model runs on the device itself, bigger, more evolved AI model is running on the neck, the edge, or the cloud side, right? So, I mean, just to summarize this whole thing, if you look at the whole telecom network, hardly there is any place where AI doesn't have a role to play, right? And with the increased complexity of these networks, right, I'm sure in the time to come, the role is only going to increase. Now, let me talk a little bit more about what our capabilities are on AI, right? Now, as you might have already appreciated by now, we are a telecom product engineering organization. I mean, telecom is something which is in our DA and DNA. We have been building telecom products, so that's one piece of it, and that's probably the reason why we also understand a lot of problems that telecom operators or OEMs face, right? Because these are things that you learn from your experience, right? And as I mentioned, one of the natural evolution for us in terms of what additional to do was the AI thing, right? So we started investing into this way back, right? And we have built certain AI solutions as well, which means that we've also got a first-hand understanding of how these AI products get evolved, how do they integrate, what are the challenges that come into picture, right? And how do you solve them, right? And this is clearly something which is into the organization's vision as well, because moving tomorrow, we see that, say, anything to do with 6G or anything to do with upcoming networks, AI is going to. So we're doing a lot of R&D into this. We are building teams, we're building solutions onto that, right? And that's one of our key areas where we are investing, right, to improve further our capabilities, right? And at the same point of time, we are also building customized solutions to actually take care of some of the existing challenges. Let me talk about one of the interesting use cases, right? And this will just give you a glimpse into how AI actually helps telecom operators, right? Now, one of the key indicators or KPIs for any telecom network, right, is the voice quality as perceived by the consumer, right? Because at the end of the day, operators may say that, okay, we have the smartest, we have the biggest network, right? But then at the end of the day, the moment of truth is with the consumer or the person who is making a call, right? And this is one KPI, right, that a lot of operators get challenged when they have to measure it, right? Because at the end of the day, they don't know when I, as an end consumer, is calling somebody else, what is the voice quality that I am getting, right? And these are, by the way, difficult things to get, right? You have millions of subscribers making calls, right? How do you understand that? Okay, what is the voice quality, right? So in the past, what people have done is that they've taken limited beta testers, right, or small groups of friends and family, sort of a section of people, right? They've tried to record calls, right, and compare them with the reference signals or between the original, what was spoken, what was the voice quality there, what was received, and then sort of tried to calculate the mean opinion score, right? But then that is something that doesn't scale up. That is not something which is dynamic, right? That doesn't give you a very real time information, right? So what we have done is that we have come up with a AI-powered mouse prediction solution. We call it the Vonet IQ. What we've done essentially here is that how do you use AI to actually predict the voice quality the end consumer would be getting based on some of the parameters that can be captured from the network, right? So things like his jitter, latency, packet loss, radio KPIs, right? So we have enhanced a model, right, wherein a number of these KPIs go into it, right? And then it predicts a MOS score, right? And the way we've tried to actually verify this whole solution is using our AI model. We've tried to predict MOS values. We've also used standard libraries to actually predict MOS values, and then we've tried to compare the results, right? So we've got very good results with our solution as well, right? And as we gain more data, right, the solution is going to improve, right? The other advantage with this whole thing is scalability right now. As I mentioned earlier, with traditional approaches, you cannot have a scaled up solution. But with this particular solution, since you're not recording people's voices, right, but you are taking these network KPIs, which in any case are being generated and captured within the network, right? And you have all these PCAPs and a couple of more things from the network itself, right? You can go ahead and run these, right? Plus, at the same point of time, if you look at from a solution perspective, running AI model is one thing, but apart from that, how do you actually structure this whole solution in terms of analyzing historical trends, analyzing trends from a particular location, right? How do you do future predictions, right? How do people in the operations side actually use this particular solution? So based on the feedback that we've received, right, we've tried to capture a lot of things into this solution, right? And we have a demo as well for this particular thing, right? The other thing that we've done are edge related scenarios, right? So MEC or the edge computing is something which is very fundamental to 5G networks, right? So what edge or MEC does is that it allows you to run applications which require low latency, right? So things like safety algorithms, things where you require some millisecond sort of timings, right? Automation for factories, right? Those sort of scenarios, right? So what we have essentially done in here is that we've come up with a distributed AI model, right? Wherein part of the AI model runs on your edge device, and the remaining part runs on our MEC, right? And which can then actually reconfigure some of the services for these edge devices as well, right? So say, for example, I have a edge camera, right? A 5G edge camera that is doing some vision analysis, right? And then you have a number of these 5G vision edge cameras spread across a large area, right? Now, each of these cameras will be processing feeds that they get, right? But the whole picture is something that gets executed at the MEC. And in case if there is some slicing related or some new orchestration that should be done, right? The MEC application can do that, right? Or if there is a need to actually spawn a new edge server, MEC does that, right? So we've done a lot of investigation into those areas as well, right? These were some of the use cases that we found quite interesting. In terms of general AI services, and since we have done these for some of our products, right? We do provide these services to some of our customers as well, right? Now, these are AI-based analytics, right? Where we do understand what kind of models we need to create, how to train, how to fine-tune those models, how to run these models offline, because that's again one of the biggest concern for any telecom operator is nobody wants to do integration with, say, some of the standard cloud API for AI kind of providers, right? They don't want to share data, right? So we've had a lot of exposure and experience with how do you run these models offline, right? We internally use chatbots. How do you fine tune these models further, right? To actually understand things a little bit better in your context, right? How do you actually integrate these AI models or LLMs, whatever you have, to your ERP systems or to things happening within your network. So that's another piece that we've had very good exposure to. Then, of course, customizations in the AI model, right? What are the various parameters you would want to fine tune? That's another area, right? Also, since we have been defining our own AI strategy, AI roadmap, right? So, whatever we have learned, whatever our vision is for this AI thing, right? We do interact a lot with our customers as well, explaining to them why we are doing these sort of things, and at the same point of time, advise them as well, right? This is how probably you should be doing things, right? Okay, moving to one of the demos that I just mentioned, probably we just walk you through is our Vonet IQ, all right, which is basically your mean opinion score calculation or MOS calculation, which is actually used by a lot of, of operators to actually see the voice quality within the network, right? So if you could just give me a minute, I'll play that demo for you.
Hi everyone, today we are introducing VonetIQ, our AI-powered tool for predicting MOS, mean opinion score, a key metric for measuring voice call quality. What sets VonetIQ apart is its ability to predict MOS without relying on audio data, making it easy and faster and more efficient for network analysis. Now let's walk through a demonstration. We will begin by selecting your circle. Let's take Delhi as our example. On the dashboard, you'll see a summary of weekly trends, the top 5 and bottom 3 most locations in the selected circle, and a geographical view. Traditionally, most scores require audio inputs, but with VNet IQ, you can simply upload a PCAP file and the tool extracts relevant network parameters like jitter, latency, and packet loss. Now, let's upload a PCAP file and let our tool extract the call data. Now, our data has been extracted. We can select the call range to let our AI models analyze the network parameters to accurately predict more score for each call. The AI model is trained on a large data set and uses inputs such as jitter, latency, packet loss to predict MOS on scale of 0 to 5, reflecting the call quality. After processing, you will see the predicted MOS for each call, including average values for the network parameters. A statistical summary will also highlight key KPIs related to the MOS for the selected calls. You can adjust the call range and re-predict as needed. All data will be available in the report section. The tool features anomaly detection that flags irregularities in the network performance, helping you address issues before they impact call quality. It also provides comprehensive analytics to track network metrics over time for deeper insights. That's all for the demo. Thank you.
Okay, so hopefully you guys liked what you saw, right? So essentially what we are doing here is that for operators, right, we have this model wherein they can collect the PCAPs from their network, right? And this model, by the way, runs offline, so you don't have to actually share these PCAPs with Amantya or setting. If you're being an operator, you can have this running on premise as well, right? We do provide integration points in case if somebody wants to host the cloud or use the cloud-based solution. But as an operator, if I want to host this on-prem as well, right, you only need to uh, provide PCAPs, right? And this whole anonymization thing that is happening, right? The model doesn't actually look into the user's data or share the user's voice or speech, whatever is being spoken about, right? And what the operator gets is a very good idea of how the voice quality is in his or her network, right? Now that's one case, right? Now the other very interesting use case, right, is what I alluded to earlier as well, is this whole federated learning, right, with telecom networks, right? So say vision-based AI is something which a lot of people talk about, right? But then at the same point of time, how do telecom networks actually help you roll out services around this, right? So having a AI-based 5G edge camera is something that's kind of okay these days. But then at the same point of time, if you look at it from a whole network perspective, right? So look at it from a big uh, smart city sort of a perspective, right? Wherein you have multiple of these cameras, right? So each camera is responsible for one particular area, right? But then all these cameras, they are connected to your MEC server, right? Where the AI model running on the MEC is able to take a more complex decision, right? So say uh, at a wider block level, right? It sees that there is a congestion setting up in one place within the block, right? What it can do is that the AI models running at the MEC, right? They can integrate with the with the traffic management systems, and they can reroute traffic from another block, right? So that the congestion gets easily cleared, right? So that's another very powerful thing, right? I mean, the whole idea behind thing is how actually telecom networks facilitate these sort of architectures. And in any case, since this is running on the MEC, so you don't have to worry about latency. These are real-time decisions that one takes, right? Uh, Talking a little bit more about this, a similar scenario can be your disaster management, right? So say there's a big disaster area, right? You have your set of first responders wearing these body cameras and then other sensors, right? Now, all this data gets accumulated or gets relayed to your central AI model running on the telecom MEC, right? Wherein then the AI model is actually able to generate a bigger picture of the whole scenario, right? And then based on that, it can take more evolved decisions as well, right? Similarly, if you have Gen AI also plugged into that, right? So your LLMs, the first responders can actually ask questions to these LLMs, and they can then better guide because they have a bigger view of what is happening within the whole disaster zone, right? And these are real life scenarios, right? Where in evolving telecom networks, they actually play a role to actually give better services to the end users, right? So hopefully it gives you some glimpse of how AI either plays some role into the AI into the telecom network, or and plus how at the same point of time telecom networks are also facilitating because of their evolving architecture, creation of new services, and come up with things that are more relevant to different scenarios, right? So yeah, I hope this gave you some background into what Amantya is, what is the kind of work that we are doing on AI, right? Some of the applications that we are building, plus our view into this whole thing, right? And probably we can now move into our next section, which is the Q&A section, right? And probably I can try to answer some of your questions.
Right. Thanks, Gaurav. That was a very interesting discussion and demonstration. We will now take up the questions. Please share them in the Q&A window. Okay, I see there are quite a few already lined up. So I'll take the first question. 1 second. How do you validate the accuracy and reliability of the AI models used in VonetIQ? Gaurav?
Yeah, thanks, Rohina. So yeah, that's a very important, critical question, and probably that it gets tied into that whole larger question of building trust for any AI solution, right? So what we've done is that there are essentially two things, right? One is every time when we predict the result of MOS, right? We have been comparing it using standard off-the-shelf solutions as well, right? And actually seeing that, okay, how far or close we are to the results from the commercially available off the shelf solutions that a lot of operators are, right? So that's one part. And we do, I mean, currently we are close, more than 90% accurate on that. At the same point of time, what we've also done is that we've come up with a feedback mechanism based on some of the observations that the operators or the operations people or people in the field they see based on our model. And these feedbacks then go back into retraining our model, right? So say, for example, if there are set of areas or set of places where people say that, okay, they haven't got a good voice quality, right? But based on some of the predictions that we've made, the voice quality should be okay, right? We take additional data, right, and kind of retrain our model, right, to actually further fine tune this thing. And as this whole solution gets more and more widely deployed, I'm sure the accuracy will keep on increasing. Yeah. Back to you, Min. Right. Okay, that's an interesting question, and probably that ties to again. Look, the thing with the existing solutions is that say, libraries from Polka or whatever it is that they need your real recordings, right? Now, no operator, right, can actually get these recordings on a wide scale, right? No end consumer is going to allow people to record their calls, operators to record their calls, and then feed into essentially these solutions, right? And by the way, there are certain open source solutions as well, right? But the whole problem is these solutions don't scale up. At the end of the day, you can do certain drive tests. You can actually have a very small test of beta testers, a group of beta testers, right, spread across few places within the network, right? But then they are going to be few and far in between, right? So you don't get a holistic picture with that, right? Because these solutions don't scale. Now, with AI-based models and models that take a lot of other parameters into account, right? These may be radio KPIs, these may be things happening on the user plane, these may be things happening at the SIP interface, right? With these sort of models, right, the solution scales up very well, right? So you can have these AI models crunch these numbers, right, very fast and efficiently, right? So at any point of time, say you go into a cell, right, you can predict MOS value of thousands of calls, right, which simply isn't possible with traditional libraries or traditional solutions, right? So one of the key advantages that this solution provides is getting a better picture, scalability, right? So that operators get a wider view of what is happening to your network, right? Back to you, Rohina.
So Gaurav, the next question is, how do you manage updates and retraining of AI models deployed at the edge?
Okay. Yeah, this is again something very interesting because from an operator's perspective, if you see, right, if you cannot update a model, manage a model, right, probably that's just half of the story, right? So essentially what we have done is that we've broken this whole problem into a set of components, right? So you have your training or retraining servers, right, which can either be deployed uh, either at the edge, right, or on the cloud, right? We have our device management solution also plugged into that. So based on different triggers, right, the whole retraining happens, right? Once the retraining happens and through our CI/CD pipelines, it gets validated, right? We trigger our device management solutions, right? That then they actually go ahead and then update some of the models that are running either on the Mac, right, or on the device itself, right? So it's a combination again of some of the pieces that telecom networks already have, right? So it's the device management servers, Mac, plus the 5G edge device, right? So hopefully that answers this question. Back to you, Rohina.
Yeah, Gaurav. We have another question on MOS prediction. Are these MOS predictions validated with real-time results? What is the prediction accuracy?
Sure. As I mentioned earlier, we do compare the results that our AI model has with a lot of open, commercially available, off-the-shelf solutions, right? I mean, the data that I have at this point of time is that we have 90% plus accuracy at this point of time. And as I mentioned, the more data we get, right, the more accurate it's going to become. Back to you, Rohina.
Yep. With LLMs usage leading to token cost increases anxiety for telecom leaders on variable cost. Do your products support particular LLMs from OpenAI or also support source LLMs?
Sure. Again, this is a very interesting question. And again, probably this is one area where we, at the very outset, right, were very clear on this thing. Since we came from a telecom background, we understood the concerns of the operator, right? One is, of course, sharing of data, and the other is cost, right? And this is something that the whole world recognizes, right? So you have this whole AI open source movement, right, happening. Meta is also playing a big role in that. A lot of other things also happening, right? So if you look what has been happening, at least with Llama, right, and that's one of the LLMs that we have had a lot of exposure and experience with, and not only the base models from Meta, right? There are other models as well. We've fine-tuned these models further based on some of the operator data, telecom specific things. We've done that, right? And these are models that you can deploy on premise, right? Again, we've had exposure in deploying these models on a small footprint or smaller hardware, right? Desktop workstations, smaller cards, right? So probably NVIDIA a 4090, something on those lines. Again, it's a bigger thing, right? But still, then you can also deploy these models on, say, data centers if you have uh, bigger training data to actually fine tune this whole thing. So something on A100 on those lines as well, right? We've also kind of quantized these models further. Of course, there are a few things that are already available, right? But then we further quantized these models. So in case if there are edge devices, again, NVIDIA Jetson boards or something on those lines, you can go ahead, deploy these models. You can ask questions, fine tune these models, right? So in those terms, yes, we've addressed those key concerns of the telecom operators, wherein they don't want to use chat GPT or likes of those. They don't want to pay for that. Plus, at the same point of time, they don't want to share data. So everything can be run on premise. Back to you, Pragna.
Gaurav, we're running out of time. A couple more questions is good for you.
Yes, I can spend another 5 minutes. Yeah.
Okay. So we have another question on VonetIQ. VonetIQ predicting MOS score is interesting, but why have you thought about predicting call drop circle-wise? I'm sure operators would be more interested in call drops or UEs going to RLF as well.
Okay. So again, there are various ways to look at it, right? And to be very honest with you, these are things that evolve as you create solutions or as you deploy solutions, right? Now, one of the key areas for operators is to actually get the voice quality circle wise. And then, of course, what Vonet does is that within a circle, right, you can then have multiple, say, Gnode Bs or cell locations, right? So a circle may be as big as, say, a state. Typically in India, that is what it is. But what this Vonet does is that once you select a circle, right, you have the ability to configure various cells, various smaller or micro locations within this thing, right? Now, whenever you have these PCAP files, you can provide a lot of metadata with it, right? And this metadata actually gives you more information on the location, coordinates, node IDs, etc., of the location from which this data was gathered, right? And then, of course, you can predict MOS and then create these analytics and these beautiful graphs, right? And when, as an operator, I see a circle, right, I have that option that, okay, within this circle, I zoom into one of the micro locations. It may be a cell, it may be something bigger than that, and then see what is happening on that particular micro area cell, what time, and see what the results are, right? So say, for example, I have a micro location in one of the business areas, right? So within Gurgaon, right? And I see probably between 9 and 11, there are a lot of call drops happening, or MOS quality gets degraded, right? So that gives me a hint that probably because people are moving, there's a lot of morning rush, right? And that gives me a hint that, okay, probably I need to add more resources onto this. And in case if my network is dynamic, right, probably reorchestrate the network at that point of time and create a new slice during that duration. So yeah, the solution is quite extensible in that sense, right? Back to you, Rohina.
Thanks, Gaurav. I think we'll have to wrap up now. We are already over the time. So, and most of the questions, have been addressed by Gaurav, though I do see a few more. We have noted these and we'll respond to them offline. So with this, we come to the end of today's session. Thank you all for joining us. We hope you found the webinar insightful. Feel free to reach out to us at connect@amantyatech.com if you have any further questions or would you like, you'd like more information. The recording will be available soon for your reference. Stay tuned for more updates from Amantya, and we look forward to seeing you in future webinars. Bye-bye.